What kind of situations are described by quadratic functions? So in part A, the equation of the function that describes the situation is given, and we will analyze the situation. So part A, how high is the balcony above the ground? Well, if the ball is thrown from the balcony, then at time 0, the ball will be at the height of the balcony. Okay, so at t equals 0, the height of the ball is the height of the balcony. So we need to evaluate h of 0. The height at time 0 is negative 5 times 0 squared plus 20 times 0 plus 60, which is just 60, and the height is measured in meters, so it's 60 meters. Express the equation of the function in vertex form. So this, we're going to basically do a completing the square, as we did in the previous lesson. So here is our function, negative 5t squared plus 20t plus 60. Factor out the negative 5. T squared, 20 divided by negative 5 is minus 4t. Leave some space, plus 60. Negative 5 bracket t minus half of this is 2 minus 2 squared. Negative 2 squared is plus 4. At this point we also want to subtract 4, but it gets multiplied by the negative 5. We're really subtracting the 4 inside the brackets. When we take it out, it'll be minus 5 times minus 4, which is plus 20, and that gives us plus 80. So we have the equation in vertex form. What is the maximum height of the ball above the ground? Well, remember the maximum occurs at the vertex, and the coordinates of the vertex in this case are 2, positive 2, right 2, and 80. So the maximum height above the ground is 80 meters. How long does it take the ball to reach that height? Again, comes out of here. This is 2 units to the right, or 2 seconds. So that will be 2 seconds. But we're asked to determine, oh sorry, no we're not. So just 2 and seconds. Now we're asked to determine, part E, determine when the height of the ball is 45 meters. So what we're going to do, the height is the h of t. And so for h of t, well, let's write out the equation again. H of t is negative 5 t squared. As a matter of fact, let's use our vertex form. So negative 5 t minus 2 squared plus 80. So our height, 45, is negative 5 t minus 2 squared plus 80. Let's subtract 80 from both sides. 45 minus 80 is negative 35. Negative 5 t minus 2 squared. Divide both sides by negative 5. 7 is t minus 2 quantity squared. In order to solve this, we take the square root of both sides. So plus or minus root 7 is equal to t minus 2. So t is equal to 2 plus root 7, or t is equal to 2 minus root 7. Now root 7 is over 2, and working out this time would give us a negative value, so we are going to reject this solution as it will give us a negative. So 2 plus root 7, and that's measured in seconds. Determine when the ball hits the ground. Now in this case, when the ball hits the ground, the height will be 0. So negative 5 t minus 2 squared plus 80. Subtract 80 from both sides. Negative 80 is negative 5. T minus 2. I'm on the edge of my tablet here. T minus 2 squared. Divide both sides by negative 5 gives us positive 16 is t minus 2 squared. And we're going to square root both sides. The square root of 16 is plus or minus 4. Remember, when you're taking square roots, it's always plus or minus. So t is equal to 2 plus 4, which is 6 seconds, or t is equal to 2 minus 4, which is negative 2 seconds, and we will reject negative times because of the situation that we're doing. Sketch the graph of the function, labeling the axes and the vertex. Okay, so what we need to do here is sketch. We only need to deal with positive times and positive heights. So we'll call that time, the time axis, the height axis. We know that it's thrown from a height of 60 meters, that it reaches a maximum height at a time of 2 seconds. So there's the vertex at 280. This is the y-intercept, or really the h-intercept at 0.60. And, excuse me, we know we hit the ground at 6 seconds. So this is the point 6, 0. So there's a graph of the function. We've got the t-axis, the h-axis, the vertex, and we've also labeled the intercepts. State the domain and the range of the function. The domain is the set of all t such that the t, the time, will be between 0 and 6. And the range is the set of all heights. And we know that the heights will go from 0 to 80. And a closed brace bracket to say the set. Okay, part B, we need to determine the equation of the quadratic function that describes the situation. So this situation, two numbers have a difference of 12. Determine the numbers if their product is a minimum. It means when I multiply them together, we're going to get the smallest value. So, step 1, label variables for what you're trying to find and what you are minimizing or maximizing. So we're trying to find two numbers. So let's let x and y be the numbers. And p be their product. Okay, so we're trying to find two numbers. Those are going to be x and y, and the thing that we're minimizing or maximizing is the product. Write the equation for the variable you are maximizing or minimizing. You might have to do some extra work to get the functions in terms of one variable. Well, the product is the product of the two numbers, so it's x times y. But we need to have only one variable. So what do we know about x and y? Well, we know their difference is 12. So if x is the larger number, we can write x minus y is equal to 12, which means that x, isolating for x, would be y plus 12. And coming back over here, the product, instead of x now, we're going to write y plus 12 times y. So we now have an expression for the variable we're minimizing, and again, it must be in terms of only one variable. Express the quadratic function in standard form, so we're going to multiply this out. We'll get y squared plus 12y, and also in vertex form. So, vertex form, we're going to complete the square. I'm going to go y squared plus 12y, leave some space. There is actually nothing to write there. I need to write a binomial y plus half of 12 is 6 squared. Okay. When we square the 6, we're going to add 36. No number in front to worry about. And we're just going to come out here and subtract 36. And then that comes down here. And we have our vertex form. Write a maximum minimum value statement. Okay, we know the maximum or minimum occurs at the vertex. Since this opens up, we have an a value of positive 1, it opens up, then we have a minimum value. So we would say the minimum value of, what is that minimum value? It's the Q value, minimum value of negative 36 occurs when y is equal to negative 6. So one of the numbers is negative 6. And x is equal to, and we look back up here, x is equal to negative 6 plus 12. I'm running off my tablet. Plus 12. So x is equal to 6. Read the question again and determine what was to be found. Write your answer in sentence form. So if we look at the question, we were supposed to find the minimum product of two numbers that had a difference of 12. Do these numbers differ by 12? Yes. From negative 6 to positive 6 on the number line is 12 units. And we were supposed to find a minimum. Do we have a minimum? Yeah, the product, negative 6 times 6, is 36. So write your answer in sentence form. What were we supposed to find? The minimum product. The minimum product of negative 36 occurs when the numbers are 6 and negative 6. Okay, number 3. The cost of a ticket to a hockey arena that seats 1,000 people is $12, and at this price every ticket is sold. A survey indicates that if the price is increased, for every $2 increase, the attendance will fall by 50. Determine the maximum revenue and the ticket price that will give the maximum revenue. Okay, so in step 1, we are going to let x be the number of $2 increases. How many $2 increases? And we're going to let r be the revenue. That's the thing that we want to maximize or minimize. So remember, the first step is finding, label the variables what you're trying to find, the number of $2 increases, and what you're maximizing or minimizing. Step 2 is to write an equation. So we know the revenue will be, well, if it was 1,000 people and $12 for every ticket sold, that would be $12,000 under normal circumstances. This time we're going to have 1,000 people, but we're going to lose 50 for every $2 increase. So it'll be 1,000 minus 50x. So if I have one $2 increase, 1 times 50 is 50, I'll have 950 people attending. 2 increases, and will be 50 times 2 is 100, we'll have $900. But how much money will we take in then? Right? So remember, would have started as 1,000 times 12. Well, in this case, 12 plus 2x. One $2 increase, 2 times 1 is 2, plus 12 is 14. Two $2 increases, 2 times 2 is 4, plus 12 would give us 16. So now we have an equation for revenue. All right, step 3, we are going to express the quadratic function in standard form. So basically, we're just going to take what we have here and we're going to FOIL it out. So 1,000 times 12, 12,000, that's the first. Outer, plus 2,000x. Inner, 50 times 12 would be minus 600x. And last, we have minus 100x squared. Okay, so proper standard form would lead with the x squared, negative 100x squared, plus 1,400x, collecting the like terms, plus 12,000. All right, now we need to do completing the square to get this into vertex form. So what do? We factor out the negative 100, giving me x squared. 1400 divided by 100, and its negative will be minus 14x. Leave some space. Plus 1200. Equals negative 100. We come down here, we want to write the completed square, or the square of the binomial. To do that, we take half, so it's x. This sign, minus half of 14 is 7. That's squared. In order to do this, we got to square the 7. We're going to get a plus 49. So we're going to subtract 49, but it's going to be multiplied by negative 100. So that's going to be plus 49 times 100. Giving us a plus here, a very emphatic plus. So it will be, oops, left a 0 off there. That's 12,000 plus 4,900 is $16,900. So what do we have? We have a max revenue, maximum because this opens down, so max revenue of $16,900 with 7 when x equals 7. Okay, so that's 7 $2 price increases. So our price, that's up here, this is our price. So the price, this other one up here, this is the number of tickets. And the price is 12 plus 2 times, running off the tablet, 7 or 26. So we need to make a final statement. If you read the question, determine the maximum revenue. Okay, so the maximum revenue, the maximum revenue of $16,900 occurs when the ticket price is $26. One more to go. Okay, a rectangular lot is bordered on one side by a stream and on the other 3 sides by 600 meters of fencing. Determine the dimensions of the lot that will produce the maximum area. So if you remember Peach's perfect pen, that was a square, but in this case we already have one side. So let's just draw a little picture. So here's the stream, and I have 3 sides of fencing, and let's call this a width, and this is a length of fencing, and this is another width of fencing. So what I've done on the diagram basically is to define my variables, right? Step 1 was label the variables for what you're trying to find. And what are we trying to maximize? Well, we're trying to maximize area. So let A be the area. Okay, well, what do we know about A? A is length times width. And in step 2, we're writing the equation for the variable you're maximizing or minimizing, right? We're trying to maximize the area, and area is length times width. But that's 2 variables, so we need to get that down to 1. Well, we know that the length plus 2 widths is equal to the 600 meters of fencing. So the length of the fencing will be 600 minus 2w. Let's take that and go back to our area expression. So area is length, 600 minus 2w, times width, which is w. That's step 2. Step 3, express the quadratic function in standard form. So let's multiply this out. I'm going to do a little rearranging while I do that. Negative 2w squared plus 600w. Go for completed square form or into vertex form. Factor out the negative 2. Gives me w squared minus 300w. Remember, this negative times the negative will give us plus 600. leave some space, close parenthesis, and we don't really have anything to add on here. There is nothing else in this equation. Okay, so we go down and we're going to write our binomial minus half of this, minus 150 squared, and we square the negative 150, giving us plus 22,500, 22,500. Now this line is now different from this line, so we have to subtract 22,500 in here, but as it comes out of the brackets, because we just want these brackets to be the three terms in the perfect square trinomial, it's going to get multiplied by negative 2, so negative 2 times negative 22,500 is plus 45,000, and that needs to be on this line as well, plus 45,000. So we have a maximum area of 45,000 square meters when the width is 150 meters. And that makes the length 600 minus 2 times 150, or 300 meters. Okay, so let's just kind of specify that. Maximum area when W equals 150, and L is 600 minus 2W is 600 minus 2 times 150 is 300. So L is 300. So final statement. What were we trying to find? Again, going back to the original. A maximum area of 45,000, and now the units come in, meters squared, occurs when the width is 150 meters and the length 300 meters. And that concludes this worksheet.